All right, this section is on asymptotes, specifically thinking about rational functions as opposed to asymptotes from other things, because in rational functions, asymptotes, vertical asymptotes, horizontal asymptotes, and then also wholes, which are not the same thing but are related. Those come up a lot in calculus because we deal with a lot of rational functions. So I'm going to go through the method we use for finding them based on what you would have learned in a pre-calculus level course, and then kind of discuss a little bit about how it will be different when you see it in calculus. So the instructions for this are just going to be to find your vertical, horizontal asymptotes, and then also to find the wholes. So for the first example, we're going to have y equals 2x squared plus 6x over x squared plus 5x plus 6. And so what we do to look for vertical asymptotes and wholes is we factor the numerator and we factor the denominator, and we look to see if any factors cancel, and we look to see what factors remain when we're done canceling things, and then that will answer those two pieces. So for the top, we have a GCF of 2 and x, and so if I take those out, I'm left over with x plus 3. On the bottom, I'm looking for what multiplies to 6 but adds to 5, and so that would be 2 and 3. So x plus 2, x plus 3. So I can see that I have a factor of x plus 3 that would make a 1, and so those cancel. And so that tells me that I have a whole at an x value of -3. And I have a vertical asymptote at an x value of -2. So I'm going to say my vertical asymptote is x equals -2. The whole has an x coordinate of -3. Okay. So now what I'm going to do, I know the x coordinate of the whole. I want to be able to determine what the y coordinate of the whole is. So I'm going to go ahead and take the x value and plug it in to the x's that remain in the function. So I've got 2 times -3 divided by -3 plus 2. So I've got -6 on the top, -1 on the bottom. So that means the y coordinate of the whole is 6. Okay. So I'm done with the vertical asymptote, done with the whole. Now I need to find the horizontal asymptote. And so I look at the two terms that have the highest degree in the numerator and the denominator. And so I can see that the highest degree is 2. It's the same. And so that means that I do have a horizontal asymptote. Y equals, since those are the same, then I look at the coefficients. I have 2 on the top and 1 on the bottom. 2 divided by 1 is 2. So horizontal asymptote y equals 2, vertical asymptote x equals -2, whole at -3, 6. All right, so what I'm going to do next is I'm going to show you guys how to check for these answers in a calculator, just to make sure that you've gotten them right. So I did not prepare this ahead of time. Okay, so if I do second y equals, or alpha y equals, so I can plug this in as a fraction. You can plug them in as a fraction. Sometimes I'll say it's better to plug it in not as a fraction, and we're not really going to see why on this problem, but I can kind of show you. Well, I can show you anyway. So I've got the function plugged in. Based on the numbers, a normal screen, -10 to 10 is going to make sense for us. So I'll go ahead and graph it like that. And so you can see here's we do have that horizontal asymptote of 2. That appears to make sense for the problem. I do have a vertical asymptote of -2, but if I want to verify that that is the case, I can do second trace, option number 1, and I can try to plug in -2. And there's no y coordinate there because that's an x value that is outside of the domain. And then if I want to check and see if the whole is correct, I can go ahead and try to plug in -3. Again, I don't have a y coordinate that goes with that, so I know that that's another value that was excluded from the domain, those two numbers that made the denominator equal 0. But if I want to see if that y coordinate of 6 was right, then I can try plugging in -2.99. See, that's a little bit above 6. -3.001. That's a little bit below 6, and so that really is me checking the left side of the hole and the right side of the hole and just making sure that those two sides have numbers that are very close to 6. And what I've done as I've plugged in those decimals is I'm actually checking to see if the left-hand limit and the right-hand limit are approaching the same number. I'm verifying that the limit as x approaches -3 is 6. So that's something that we learn a lot in calculus, is if there is a problem where I can't actually plug in 3 and evaluate something, I can at least find the limit of what happens if I'm looking at an x value of -3. And so in calculus, we will probably not take this approach because that's pre-calculus. In calculus, to find the whole, we will find the left-hand limit and right-hand limit and basically do this work in our heads because it's faster, but we'll use calculus to defend our answers. And then for something like a horizontal asymptote, we call those end behavior asymptotes because we're looking what happens as x goes to the left forever, it approaches 2. What happens as x goes to the right forever, the y value approaches 2, and those are limits. And so that would be how we would determine our horizontal asymptote in calculus. But sometimes it's nice in calculus to be able to fall back on what you've learned before to make things a little bit easier to find. Okay, so we'll be learning these in a slightly different way in the future, but it would be nice still to remember this information. All right, number 2. And these would be overly simplistic for a calculus course. You would see problems that are much more difficult. But it's still nice to be comfortable with this part so you don't get hung up on stuff later. All right, so 10x plus 20 on the top, and then on the bottom we have x to the third minus 2x squared minus 4x plus 8. And so again, we're going to do the same process. We have a GCF of 10 on the top. And then on the bottom, it looks like it's a factor by grouping problem. So I'll go ahead and kind of think about splitting this in half. Between the first two pieces, I have a GCF of x squared. I'll write it over here, x squared. And then I have an x minus 2. Between these two terms, I have a GCF of 4. But I don't want to have a negative x in here. I'm going to take out a negative 4, actually, because I do want this to be a positive x written in the parenthesis so that it will match up with this one over here. So dividing by -4, I get x. Dividing by -4, I get -2. And now I can see that those parentheses are exactly the same. So I have a GCF of x minus 2, and then I have x squared minus 4 as leftovers. And that x squared minus 4 can actually be rewritten. That would be x plus 2 and x minus 2. So I'm going to go ahead and kind of get rid of that and say x plus 2, x minus 2. Okay, so now I can say these two cancel. So I have a vertical asymptote and I have a hole for this problem. The hole has an x-coordinate of -2. I have two factors left, but they both kind of determine that vertical asymptote. And so the vertical asymptote has an x value of +2. So now I can go ahead and take that +2, or sorry, take the -2 for the hole and plug it into the leftover factors. And so we can determine what the y coordinate is. So I do have 10 on the top, and then I've got -2 minus 2 is -4. -2 minus 2 is -4 again. And so I've got 10 over 16, which would be 5 over 8. Okay. And then over here, we're going to determine what the horizontal asymptote is. So I'm looking at the terms with the highest degree, or the highest exponent to determine the degree of the numerator and denominator. The numerator has a smaller degree than the denominator, so that means that the horizontal asymptote is y equals 0. Okay, and again, so actually I'm going to show you the annoying part of what we did last time when we plugged this in as a fraction. I'm going to show you what the annoying part is. If you want to see like, oh, what happens at x equals 1, it gives you 2/3, x equals 2, 3, 4. It's always going to spit out your y coordinates as fractions, which is fine if you're really good at fractions, but can be frustrating if you're trying to graph something and you're not great at fractions and the fractions are kind of crazy. So if you want to avoid having your outputs be written as fractions, then you need to input the function not as a fraction. So don't use the fraction function. So what I'm doing here is I'm putting the numerator in parentheses and I'm dividing, and then I'm going to put the denominator in parentheses. And so when I do the problem this time, it is not going to do fractions, which is going to be helpful when I try to compare the y coordinates to see if they're very close to the hole that I found or not. Okay, so based on the drawing, or the graph, it makes a lot of sense that we have that horizontal asymptote of 0. I can kind of see it's approaching that. If you want to be able to see that in a graph, if you hit the trace button, it brings that cursor up there and then you just can follow it. So I can see that as I go to the left, that y coordinate is getting closer and closer to 0. And that kind of confirms for me that there's an asymptote there. Now I can go ahead and check plugging in +2, and I can see that there's no value, so that fits. That's my vertical asymptote. I can try plugging in -2. I can see there's no y value. That kind of confirms that there was a hole there. If I want to make sure my 5/8 is correct, 5/8 is 0.625, so now when I check the left side of the hole and the right side of the hole, I want to make sure that I'm getting close to that decimal. So I'm getting close to 0.625, getting close to 0.625. And the more decimals you use, the closer you're going to get. All right, that's kind of how limits work. And so if you're checking those answers, that's what you can do if you're not quite sure. All right, last one. We're going to do y equals 1 over x minus x over x plus 2. All right, so the way this one is written, we can't work with it yet, so what we need to do is get a common denominator. That means that the first fraction needs to be multiplied by x plus 2 on the top and the bottom. The second fraction needs to multiply by x on the top and the bottom. So this is going to be x plus 2 over x times x plus 2 minus x squared over x times x plus 2. And so we end up with negative x, because it's, or sorry, negative x squared, because that was being subtracted off, plus x plus 2 over x times x plus 2. So that's we can look at our function that way. And then I'm going to go ahead and factor that -1 out so that I can factor this problem. So got -1 x squared minus x minus 2. And now I'm going to go ahead and do the factoring portion so I can find my other answers. So something that multiplies to -2 but adds to -1 would be x minus 2, x plus 1. Keep that negative out in the front. And then x and x plus 2. Okay, so as long as I didn't make any mistakes, and I feel not very confident because I have a lot of steps there, and I went kind of fast. As long as I didn't make any mistakes, this problem appears not to have a hole. It appears to have 2 vertical asymptotes. So I'm going to say vertical asymptote at x equals 0, x equals +2. I did not put 0, 2 because these are equations of vertical lines. It does not make sense for you to write an equation of a line and put a comma in the middle of it. That would be weird. So x equals 0, x equals 2. For the whole, I'm going to say none. When I look back here, I can see that the degree of the numerator is greater than the degree of the denominator, so that tells me that for the horizontal asymptote there are none. In pre-calc, since the degree of the numerator is exactly 1 bigger than the degree of the denominator, oh, that was a terrible place to tell. You guys, I almost made a rookie mistake. Hopefully you're picking up on this, that you can't see it because that's not actually the degree of the denominator because it's not multiplied out. Anyone catch that before I said it? Hopefully. If this had been distributed, that would have been x squared plus 2x. Goodness gracious. That's actually the same. Huh. All right, so that means the horizontal asymptote, there is one. It is y equals, since the degree is the same, we have to consider the coefficients. -1 divided by +1 is -1. Okay. The reason I was automatically going into that spiel is I figured that maybe I gave one example that didn't have a horizontal asymptote. So if the degree of the numerator was bigger than the denominator, then we would have had an oblique asymptote or slant asymptote. And if you remember from pre-calc, that means you have to do polynomial long division. If the degree was exactly a difference of 1, then you could find where the top was bigger than the bottom by 1. You would find the equation of the horizontal of the slant asymptote, and it would be in the form y equals mx plus b. That is something we do more of in pre-calc, and in calculus it doesn't really happen. Like it's not really information you care about. So that's kind of the nice thing, is that we've kind of moved past that, I guess, or maybe it comes back later, but it doesn't really happen to you guys this year. All right, hopefully you are still with me, that when you are checking stuff like this, you always make sure that you're looking at that expanded form of the equation, not the factored form. None of it can be factored for you to know what the highest degree is and to be able to find that information for your horizontal asymptote. So do not make the mistake I did. All right.